This section of the notes is going to cover the pre-AP section, which is the last page of completing the square. So just to recap, we just covered talking about completing the square. Remember, it works best when A is 1 and your B is an even number. The only requirement, though, is that A has to be 1. B doesn't always have to be even, but if it is even, it makes our life a lot more easier. But if it's not even, then we have some issues, but we'll resolve them, obviously. But A does have to be 1. That's the only way that completing the square works. Now remember, in number 1, when we were completing the square, right, so I got to the point where I had to solve by taking a square root, and the square root of 60 is not a whole number, so I left it as square root of 60, and I remembered that plus or minus at the front, and then I go ahead and I simplify square root of 60 at the end. Now, is it required to write your answer separately like this? No. Because 2 square root of 15, if I were to type that in the calculator, that's a decimal. It doesn't come out to be like a nice regular number. Then I can't split my answer and like really combine or simplify. Whereas in number 2, when I took the square root of 64, I got 8. Like I got a whole number 8, positive or negative 8. Now 8, you keep it as positive or negative 8, and you move that 7 over, so then you have 7 plus or minus 8. And then you realize, oh, well, 7 and 8, those are regular numbers. I can combine those. Like if I were to type that in the calculator, I would get a regular number when I combine them. So I have 7 plus 8, which is 15, and then I have 7 minus 8, which is negative 1. So remember, sometimes you do have to split and keep going, and sometimes you just stop. Here you would split 7 and 8 apart and then keep going, whereas in the last problem, you have a radical left over, and when you have a radical left over, you don't split and keep going. All right, so let's start with number 5. W squared minus 5w equals 11/4. Well, remember, first step of completing the square is you want all your variables on the left and all of your numbers on the right. Now, if you're given a choice to solve by completing the square, I would choose not to solve because there's always other ways that you could solve that could be easier. But if you're asked to complete the square, then obviously you complete the square. Now remember, the requirement is that A has to be 1, and A is 1 here. It is 1 right in front of that W squared. Now your B value, now your B value is not even, but that doesn't matter, right? Like technically it would be a lot easier if it was, but it's not a requirement. So you're going to see some funky stuff that you didn't see with the on-level problem. So first step, variables on the left, numbers on the right, that's taken care of. The next step would be to add your blanks. So you have W squared minus 5W plus blank equals 11/4 plus blank. All right. The next step here is to create the thing that's in those blanks. So in the blanks, right, that's going to be b divided by 2 squared. Well, your b value here is negative 5. All right, so let's plug that in. We have negative 5 for our b value divided by 2 squared. Well, negative 5 divided by 2, that doesn't simplify to anything. So I just leave it as negative 5 over 2, but I square it. Well, negative 5 over 2 squared is going to be 25 over 4. You want to keep it as a fraction. Don't write a decimal. I know that you could technically write this as a decimal, but I would prefer that you keep it as a fraction because it makes life a little bit easier. So you're going to leave it as 25 over 4. All right, so 25 over 4 goes in our blank. So you'll already notice that it's not a nice problem because you have some fractions involved. All right, so 25 over 4 goes in our blanks. The next step after filling those blanks is factor the left, simplify the right. So on the left-hand side, I know that it's going to be w, because we used the variable w, parentheses squared. So it's going to be w, something inside the parentheses, but squared, equals whatever that is, and we'll deal with that later. So what goes in the parentheses here? Well, remember, what goes in the parentheses here is whatever is in the parentheses here. So we're going to plug in negative 5 over 2. So negative 5 over 2. All right, and then we're going to simplify the right-hand side. Well, if I add 11/4 plus 20, did I say the left or the right? This is the right side. If I add 11/4 plus 25/4, that's going to give me 36/4. Well, 36/4 simplifies to what here? Simplifies to 9, because 36 divided by 4 is 9. All right, after you finish factoring the left and simplifying the right, then you solve by taking a square root. So we're going to square root both sides, just like when we were learning how to take a square root. Remember, the square root and the square cancel each other out, so I have w minus 5 over 2 equals, now is the square root of 9 a whole number? It is. We get 3, but not just 3, positive or negative 3. So remember, we always have a plus or minus sign. Anytime you create a square root, you have to put a plus or minus in the front. All right, now before we start simplifying anything, we want to make sure that that plus or minus is there, because if we don't have that plus or minus there, then we're going to end up having a mistake and we only have half our answer, really. Remember, we're solving for the square, the x-intercepts here. when we're solving for a quadratic. So you want to make sure that you have all the x-intercepts possible. All right, so the next step here is we want to go ahead and get w by itself. So I'm going to add 5 over 2 to both sides. Now where's 5 over 2 going to go? It's going to go in the front. So 5 over 2 plus or minus 3. So remember the 5 over 2, whatever number you add to the other side, it always goes in front of the plus or minus. All right, then you ask yourself, do I keep going and split this, or is this my final answer? Now, you would actually split it here, and the reason why you would split it here is because isn't 5 over 2 technically a normal number? That's 2.5. Like, I can add that in a calculator. So because 5 over 2 is technically normal, even though it's a fraction, it's still normal. It's not like a repeating decimal or like a never-ending decimal. So we're going to split this up into our two scenarios. On one hand, we have w equals 5 over 2 plus 3. And on the other hand, we have w equals 5 over 2 minus 3. Well, again, you can keep it as a decimal or leave it as a fraction, up to you. But 5 over 2 plus 3 is going to be 11 over 2. Or, I think that's 9.5, or 5.5, right? 5.5. Or we have w equals 5 over 2 minus 3, which is negative 1/2, or negative 0.5. So you can write your answer however you'd like, but I'm going to keep mine as fractions. So we have an x-intercept at 11 over 2 and one at negative 1/2. Okay, so you do split here because you have your regular normal numbers. All right, and then the very last section is actually pretty, it's not too bad. So what value of c would make the following expressions a perfect square trinomial? Remember, a perfect square trinomial is the ones where I can factor and it looks like this. Like I'm able to do the shortcut because it's a perfect square trinomial and I know that it's going to be the same thing but squared. So we're basically just asked to find the value of c here. Well, it's kind of like, how do I get this variable over here? You're going to do b divided by 2 squared to get that c value. So what is your b value in number 1? Your b value in number 1 is 6. We're going to do b divided by 2 squared. Right, we're going to use the formula. Well, your b here is 6, so we have 6 divided by 2 squared. Well, 6 divided by 2 is 3 squared, which is 9. So your c value that you want is 9. You want the c value to be 9 because if your c value is 9, right, if I put plus 9, then I know that the shortcut is x plus 3 squared when I factor it. So you're looking for that c value that helps us make it to where you can use the shortcut for factoring. All right, let's start with the next one. What's your b value in number 2? Well, that's going to be negative 4. And we know that we're going to do b divided by 2 squared to get that c value to get our perfect square trinomial here. Well, our b value is negative 4, so we're going to plug that in. Negative 4 divided by 2 squared is going to be negative 2 squared, which is going to end up being positive 4. So your c value here is positive 4. All right, moving on to the last one, decimal though. But again, treat it like normal. A is 1 here, so we're allowed to do that. Our a value is 1. Our b value is 2.4. Okay, so we're going to do b divided by 2 squared. Well, your b value here is 2.4. Now, because they gave you a decimal, you leave it as a decimal, right? We're allowed to do that. 2.4 divided by 2 is going to be, actually, I didn't even put that on my thing. 2.4 divided by 2 is 1.2. I don't know why I had to do that in the calculator. 1.2 squared, which is going to end up being 1.44. Let me double check that. Yep. So you want your c value in this case, if you want a perfect square, be 1.44. And if you're curious, if you were to factor this, because right now it's x squared plus 2.4x, plus the c value that we just found, so plus 1.44. If I were to factor this using that shortcut, I know it's going to be like x something squared, and the number that would go in there would be the 1.2, so it would be plus 1.2. So you basically are able to use that shortcut with anything as long as it's a perfect square trinomial. And to make it a perfect square trinomial, you'll take your b divided by 2 and square it.